Hello dear students, how are you? I hope all are fine and safe at your houses. Okay, today let me discuss the next topic is a representation of an atom. How we can represent the atom? See, we can represent the atom by using this one. Here X, A, Z. I mean X is the atom, A is the atomic mass number, Z is the atomic number. See, for example, I will give one example. See, hydrogen is the atom, X in the sense hydrogen here. What is the atomic number of hydrogen? 1. What is the atomic mass number of hydrogen? Is also 1. So it is X, it is A, it is Z. It is the meaning. Next example, helium. Helium atomic number 2, atomic mass number 4. So like that, so many examples are there. So this is the representation of an atom. You have to remember properly. Okay, now let me discuss the definitions for atomic number and atomic mass number. Okay, now let me discuss atomic number. It is represented with the letter Z. It was proposed by J Moseley. Now atomic number is defined as the number of protons present in an atom of an element. Here atom of an element in the sense, already I told you, for example H2 is an element. It is composed by H plus H. Now I am talking one of the atom of hydrogen in a H2 element. That is the meaning. Atom of an element is called atomic number. Simply atomic number in the sense, in an atom how many number of protons are there. That is simply atomic number. Remember, it means atomic number is equal to number of protons. Z is equal to P. It is equation number 1. Next, in an neutral atom, this neutral atom very, very important. Okay, in neutral atom, number of protons is equal to number of electrons. Remember, number of protons is equal to number of electrons in a neutral atom. Okay, that is number of protons is equal to number of electrons. P is equal to E. It is second equation. It is first equation. Now from first equation and second equation, we can write as number of electrons is equal to number of protons is equal to atomic number. It is simply about atomic number. This equation I have to remember, very, very important. Okay, next topic is atomic mass number. It is represented with capital A. Atomic mass number is defined as the sum of protons and neutrons present in an atom of element is called atomic mass number. See, simply in the atom how many protons, how many neutrons are there, that is only atomic mass number. It means capital A is equal to P plus N, number of protons plus number of neutrons. Already we learnt in the previous class, Z is equal to P and P is equal to E and E is equal to P is equal to Z. About these equations already we read, we know. See, now from equation 1 and 4, I will write equation like, see, A is equal to, here instead of P, we have to write Z value. In the place of P, I am writing Z value because P is equal to Z here. So, P means Z plus N. Have you understood? Now here I want neutrons, N value I want. Then N is equal to, this Z I have to send this side. Then A minus Z. So, number of neutrons is equal to atomic mass number minus atomic number. This formula very important to calculate the number of neutrons. And finally, this formula and this formula. These two formulas are very, very important to calculate the number of electrons, protons and neutrons present in the atom. Have you understood? Okay, next one, see, calculation of number of electrons, protons, neutrons in an atom. First, for neutral atom, formulas are number of electrons is equal to number of protons is equal to atomic number, neutrons is equal to A minus Z. This is the formula for neutral atom. Next, for cation, is number of electrons is equal to atomic number minus number of electrons lost. Why lost? Because it is cation. Cation in the sense, if any atom lose the electrons, then it will become cation, like Na plus. Okay, so it lost one electron. How many electrons lost? You have to substitute here. Next, number of protons won't change, never change. For cations or anions, number of protons and number of neutrons never change. We can observe the difference in only the number of electrons in case of cation and anions, remember, but number of protons and number of neutrons never change. This point I have to remember. Okay, number of protons for the cations is Z as like this only, and number of neutrons also same formula, N is equal to A minus Z. It is for cations. Now for anions, E is equal to Z plus number of electrons gained. Here lost, here gained, here minus, here plus. Have understood? Example n minus 3. How many electrons gained? 3 electrons gained. So you have to substitute here 3. Next, P value never change, N value never change. Protons same formula, neutrons same formula. For example, for neutral atom, one of the atom I considered, that is carbon. See, carbon 6, 12, atomic number 6, it is Z, atomic mass number A, it is A. Now here E value is equal to Z. According to this formula, E value is equal to Z. What is Z value? 6 here. So how many electrons are there? 6. P also Z. What is the Z value? 6. N value A minus Z. 12 minus 6. So in the carbon atom there are 6 electrons, 6 protons, 6 neutrons. Next, for cations, this is the example. See, this is atomic number, it is atomic mass number. Electrons, what is the formula? Z minus number of electrons lost. Z in the sense 11. How many electrons it lost? 1 electron it lost. So minus 1, it means 10 electrons. P value, it is Z value, it is equal to Z value. How much? 11. And N, A minus Z. A minus Z in the sense, A 23 minus 11. How much? 12. So in Na plus there are 10 electrons, 11 protons and 12 neutrons. Have you understood? Next, for anions, example N minus 3, atomic number 7, atomic mass number 14. Okay, see here E value Z plus number of electrons gained. What is the Z value? 7 plus how many electrons it gained? 3 electrons gained. Here don't think minus charge is there, so you have to write here minus charge. This formula you have to consider. Here plus is there, so plus. How many electrons gained? 3 electrons gained. 3 electrons only you have to write. Next, 7 plus 3 is equal to 10. And number of protons, it is equal to Z. Z in the sense, here it is equal to Z. Z in the sense, how much? 7. Next, number of neutrons, A minus Z. A value 14 minus 7, it is equal to 7. Remember, so in n minus 3 there are 10 electrons, 7 protons, 7 neutrons. This is simply about calculation of number of electrons, protons, neutrons. Once you have to try for all the atoms. Have you understood? Okay, next at least you have to try these examples. For neutral atom, you have to calculate number of electrons, protons, neutrons present in helium 24 and lithium 37 for neutral atoms. Next, for cations, Mg plus 2 and Al plus 3. Mg plus 2 in the sense atomic number 12 and atomic mass number 24. Here 13, 27. Okay. And for anions, example oxygen 8, atomic number 8, atomic mass number 16. Here 9, 19. These are examples you have to try. You have to calculate number of electrons, protons, neutrons present in these all. Once you have to try. Okay, next definition is isotopes. Let me discuss about isotope. What is isotope? Isotope in the sense The same elements having same atomic number and different atomic mass number are called isotopes. Okay, simply same Z value but different A value. See, for example, it is representation of atom. Okay, in this atom, isotopes have same Z value but different A values. Those are called isotopes. Remember, okay. Isotopes have same chemical properties but different physical and radioactive properties. This is very, very important. Okay, same chemical properties, different physical and radioactive properties. Next, fractional atomic masses will be there. Like for chlorine atom, atomic mass is 35.5. It is mainly due to existence of different types of isomers for same atom. Chlorine existed in two isotopes. They are chlorine 1735, chlorine 1737. That's why it is atomic mass in fractional. So it is fractional atomic mass is due to existence of different isotopes of same element. Have you understood? It is for applicable for only some elements. Next, examples how to see. Isotopes example, hydrogen 1, 2. Hydrogen have 3 isotopes mainly. In that, first isotope is H11. It is called protium. It will be there in the universe. 99.9% will be there. Hydrogen. Remaining 2 isotopes are very less in percentage. Second one is H12. It is called deuterium. Third one is H13. It is called tritium. Simply isotope in the sense same atomic number but different atomic mass numbers. That you have to remember. Second example, carbon 612, carbon 614. Carbon 614 have so many applications. What are they? Like by using carbon C14 we can identify the old things. Okay. See next, chlorine C1735 and Cl1735 and Cl1737. It is about chlorine. Okay, have you understood? Okay, next topic is isobar. What is isobar? The different elements having same atomic mass number but different atomic number are called isobars. Before in isotopes, there same elements but here different elements. This is very, very important. See, remember. And in isotopes, same Z but different A. Here same A but different Z. That is the main difference between isotope and isobar. Okay. Next, isobars have same physical properties but different chemical properties. But in case of isotopes, reverse. Same chemical properties, different physical properties for isotopes. Next, examples you have to see. Isobars examples, carbon 614, actually carbon 612, but it is one of the isotope of carbon. Nitrogen 714. Here see, it is A, atomic mass number A. It is atomic number Z. Same A value but different Z values are called isobars. Have you understood? But in case of isotopes, same Z value, these are Z values but different A values. These are called isotopes. Now here same A value but different Z values. These are called isobars. Next example, argon 1840, calcium 2040. It is A value. This one Z value. Z value is different but A value same. Those are called isobars. Have you understood? Okay, next topic is isotone. What is isotone? The different elements having different atomic number and different atomic mass number but having same number of neutrons are called isotones. Here simply this point also you have to remember different elements. Okay, here simply isotones in the sense different Z value, different A value, but in that same number of neutrons will be, that is called isotone. Have you understood? Now if you discuss about examples, then you will understand very clearly. See, first example, carbon 614, one of the isotope of carbon, oxygen 816. Okay, here this is Z value, this is also Z value, it is A value, it is also A value. A value is different, Z value is different, both different, but these having same N value, number of neutrons same, A minus Z. Let us check once. For carbon atom, I have to check. First carbon, okay, carbon I have to check first. N is equal to A minus Z. Okay, here A value how much? 14 minus Z value 6. 14 minus 6, 8. 8 neutrons will be in carbon 614 isotope. Next, in oxygen I have to check once. A value 16, Z value 8. 16 minus 8, 8. So number of neutrons here 8, here 8. Have you understood? Such a type of elements are called isotones. Okay, different A values, different Z values, but number of neutrons will be same. See next example. Otherwise, see this is sodium 1123, magnesium 1224. 11 is the atomic number, 23 is the atomic mass number. A, Z. Okay, Z value is different, A value is also different, but number of neutrons will be same. Now you have to calculate. For sodium you have to calculate. N is equal to A minus Z. Okay, A value how much? 23, Z value 11. 23 minus 11, 12. 12 neutrons will be in sodium. Next here I have to calculate. N is equal to A minus Z. Okay, see, A value how much here? 24. Z value 12. 12 minus 24 minus 12, 12. Okay, here 12, here 12. Number of neutrons 12, there also number of neutrons 12. So equal number of neutrons will be, but different A values, different Z values. Such a type of elements are called isotones. Still so many will be, and so on etc. Have you understood clearly about isotones? Isotones have different physical properties and different chemical properties. This you have to remember properly. Okay, next definition is isodiaphers. What are isodiaphers? The different elements having same isotopic number. Here what is isotopic number? A minus 2Z is called isotopic number, are called isodiaphers. Okay, what are the examples? Let me discuss, then you will understand clearly. For these two atoms have to calculate A minus 2Z. First for fluorine have to calculate A minus 2Z. It is called isotopic number. See, A value how much for the fluorine? 19 minus 2 into Z value for the fluorine 9. 19 minus 18 how much? 1. Isotopic value for the fluorine is 1. Next, for sodium isotopic value A minus 2Z I have to calculate. A value of, it is A value, A value, Z value, Z value. Okay, A value how much? 23 minus 2 into atomic number of sodium 11. 23 minus 22, 1. So here isotopic value 1, isotopic value of sodium also 1. Fluorine isotopic value 1, sodium isotopic value also 1. So these are called isodiaphers. For which elements isotopic value is same, then that elements are called isodiaphers. Remember. Okay, next definition is isotopes. What are isotopes? Isotopes in the sense those molecules having same atomicity and same number of electrons, then that molecules are called isotopes. Okay, examples let me discuss, then you will understand. CO2, N2O. First, what is atomicity? Atomicity in the sense the number of atoms present in the molecule. Atomicity means the number of atoms present in the molecule. The number of atoms present in the molecule. It is a carbon dioxide molecule. It is N2O, nitrous oxide molecule. Now here, how many atoms are there in carbon dioxide? How many atoms are there? 1 carbon, 2 oxygens. There are 3 atoms. So atomicity is equal to 3. For carbon dioxide, atomicity is 3 because in carbon dioxide there are 3 atoms. How many atoms are there in the molecule? That is called atomicity. Next, for N2O, 2 nitrogens, 1 oxygen. For N2O also atomicity is 3. Okay. Next, let me calculate number of electrons. Okay. Number of electrons in carbon, how many electrons will be? 6. Okay. Plus in 1 oxygen 8. But here 2 oxygens are there. 2 into 8, 16. 6 plus 16, 22. So 22 electrons are there totally in carbon dioxide. Okay, next N2O, nitrogen. In nitrogen, how many electrons are there? 7. How many nitrogens are there? 2. It means total 2. 7 into 2, 14. Plus in 1 oxygen, how many electrons are there? 8. 14 plus 8, totally 22. So here also 22. Okay. See, isoesters in the sense having same atomicity and same number of electrons. Okay. Such a type of molecules are called isoesters. Have you understood? Okay. Last definition is isoelectronic species. What are the isoelectronic species? Those molecules or ions having same number of electrons. This point I would remember. Same number of electrons are called isoelectronic species. Examples let me discuss. N minus 3. In nitrogen there are 7 electrons. Here 3 electrons gained. So 10 electrons are there. Oxygen 8 electrons. It gained 2 electrons. So 10 electrons. Fluorine 9 electrons. It gained 1 electron. 10 electrons. Neon, it having 10 electrons. Sodium, actually 11 electrons, but it lost 1 electron. So 10 electrons. Magnesium, actually 12 electrons, but it lost 2 electrons. So 10 electrons. Aluminium 13, it lost 3 electrons. 10 electrons. So these all ions having same number of electrons, 10, 10, 10. Okay. Such a type of species are called isoelectronic species. Okay. Next, S minus 2. Actually in sulfur there are 16 electrons. 16 electrons will be, but it gained 2 electrons. 16 plus 2, 18. Chlorine 17, it gained 1 electron. 17 plus 1, 18. Argon 18. Potassium 19, but it lost 1 electron. So 18. Calcium 20 electrons will be, but it lost 2 electrons. So 18. So same number of electrons are there in these all. Such a type of species are called isoelectronic species. Have you understood? Still so many etc. Okay, this is today's class. If you like this video, then press the like button and please subscribe my channel. Thank you. All the very best.